Okay, so good morning and welcome to second webinar in grant period 2. At this webinar, we will hear 3 presentations about the STSMs from second grant period. We will hear presentation of Nataša, Zorica, and Maryam. And I hope this presentation will also inspire new people to apply for our STSM grants and to use our network to improve the research, find new ideas, and expand the network. Also, when I have your attention, I would like to invite you for our haiku workshops. You all got the links via ecosystem, but we also recommend to register directly at Zois on your email inboxes. You have links and the information how to register. I think it's all from the news and informations, and we can start with the presentation of Nataša. The floor is yours.
Okay, thank you, Jakub. For those who maybe don't know me, my name is Nataša Jović-Jovičić. I'm Principal Research Fellow from the University of Belgrade, Institute of Chemistry, Technology and Metallurgy. I have been involved in this work of this cost action from the beginning, working within Working Group 2 and Working Group 5. And the topic of my short-term scientific mission was characterization of charcoals derived from Fruška Gora mountain sawdust using advanced textural and morphological techniques. I will try to switch the... Okay. The scientific work was carried out in Department of Materials, Environmental Sciences and Urban Planning at University of Politehnica della Marche in Ancona. Our host was Professor Maria Letizia Ruello. She supported our applications. I'm sorry, when I said our, I mean Zorica and I were together in this in the same time in this institution, but unfortunately Professor Maria Letizia Ruello was not present during our stay, but she kindly welcomed us and stayed in contact with us during our visit. In first day of our visit, we started by introduction with the equipment and laboratory guided by our host Dr. Chiara Giussoe and Dr. Natalia Czerwinska, but in the following days we had the pleasure to collaborating closely with Dr. Natalia Czerwinska and PhD student Charnela Stevin, and they were very supportive and worked with us through the mission, and I would like to thank them. The visit took place from 8 June to 14 June. Actually, we had 5 working days from 9 to 13 June. Before I start presenting the methodology and results of the STSM mission, I would like to give you a short background of my research. Biochar is the carbon-rich material obtaining by pyrolysis of biomass under oxygen-limiting conditions. It is considered as a suitable adsorbent because of several key properties. It has a pore structure, large surface area, abundant functional group. It is low cost and can be produced from waste materials such as agricultural residue and forestry byproducts. And the absorption performance of biochar can be improved by either chemical or physical activation, and activation process increased porosity and surface area and introduce new functional groups and improves interaction, and that way improves interaction with pollutants. This study focuses on the synthesis, activation and characterization of biochar derived from Turkish oak sawdust from the Fruška Gora mountain region, and the main objective was to evaluate how different chemical activators applied in different mass ratios influence adsorption capacity. The initial phase of this research at my institute started as internal project led by our young researchers, mostly PhD students at that time, with serving me as their advisor in that project. And aim of the project was to provide young colleagues practical experience in conducting and managing research projects, allowing them to gain skills in writing and purchase of equipment, planning, execution of project reporting. And at the beginning of this year, we had a technical problem in the characterization process of some exceptional equipment like bed surface analysis, and also STSM analysis was not available at that time, and this challenge motivated us to apply for short-term scientific mission within this cost action in order to get access to facilities and experimental, primarily to bed and STSM analysis. On this slide, I would like to explain the synthesis route and preparation of the biochar samples. We started with dried Turkish oak sawdust, as I mentioned, from forest of Fruška Gora region. We sourced that sawdust from a small-scale sawmill in the Fruška Gora. The sawdust was subjected to chemical activation using different activation agents, including phosphoric acid, sodium hydroxide, and hydrogen peroxide at various rations. The carbonization was performed at 400 degrees during 60 minutes in air-limited conditions. And through this procedure, we obtained 10 distinct biochar samples, and these samples were first evaluated as adsorbents in adsorption experiments, and based on the adsorption results, selected samples then will be fully characterized. We first performed the evaluation of adsorption properties of all samples in batch adsorption experiment with ciprofloxacin, pharmaceutical ciprofloxacin as a test model of adsorbent. Although the sample activated with phosphoric acid in ratio 1:4 demonstrated the best adsorption properties, we also analyzed one representative sample activated with hydrogen peroxide and one with sodium peroxide. And these were selected because within their respective groups, they show the highest adsorption capacity. Even their performance was significantly lower compared, as we can see from this graphic, to phosphoric acid activated biochar. We including them to study in order to compare the influence of different activating agents on the surface and morphological properties. The methods that we plan for the characterization include elemental analysis for determining the content of carbon, hydrogen, and nitrogen, then surface functional groups by FTIR spectroscopy. This STSM provides analysis in textural properties and in surface morphology, and we also have analysis in the point of zero charge of adsorbents. Here we can see the results of bed analysis based on nitrogen adsorption isotherms and 77 Kelvin for 4 different selected biochar samples. The adsorption isotherms show clear differences in the textural properties of the materials. For example, is untreated, so unactivated biochar, and this is for phosphoric activation, sodium hydroxide, and hydrogen peroxide. The table summarized the main textural parameters. The bed surface area of samples activated with phosphoric acid is exceptionally high, around 1060 square meters per gram, with a significant contribution of micropores, while starting sample and sample activated by hydrogen peroxide have almost negligible surface area. And some higher surface area, we found that in the sample activated with sodium peroxide, about 25 square meters per gram. Sorry, I have something to add. Micropore volume. Regarding micropore volume, it is the highest for a sample activated with phosphoric acid, confirming its strong microporous character. And average pore diameters are also provided, showing that CP sample has much smaller pores compared to other samples. So these results demonstrate that the activation process applied with phosphoric acid greatly enhanced the surface area and microporosity, making it the most promising material in adsorption study. STEM images reveal macroscopic surface feature and morphological texture. Control sample. These two images show control sample results. They are relatively compact and layered structure, typical for unmodified biochar or charcoal. Surface is appear flat and with minimal surface roughness, suggesting limited structural fragmentation. Sample with phosphoric acid display a highly organized, fibrous, and channel-like structure, possibly due to a specific activation method, and surface are more open and fragmented with visible macro-scale cavities and cracks indicated enhanced surface texture, although the micrographs or SEM analysis don't reveal micro and mesopores. The structural openness could contribute to better mass transfer in applications such adsorption, or it could be also important if these materials were used as a catalyst. Sample with activated by sodium hydroxide exhibit a rough, irregular, heterogeneous surface with visible fractures, and sample activated with hydrogen peroxide has a perforate and cracked macrostructure, showing large open features and cylinder channels at the surface. Some regions resemble vascular-like plant structures typical of biomass-derived char. Our adsorption study, we can see the adsorption performance of our biochar samples toward two pharmaceuticals, ciprofloxacin and 4-amino-antipyrin. Ciprofloxacin is a widely used antibiotic, while 4-amino-antipyrin is a metabolite of analgesic and antipyretic drugs, and both compounds are frequently detected in surface water and wastewater effluents, so they can pose risk to aquatic organisms. So the experimental conditions are summarized here. We use batch system with 20 milligrams of adsorbent and initial concentration of 20 milligrams per liter at room temperature of each pharmaceutic. And the graph shows that the removal efficiency over time, the sample activated by phosphoric acid demonstrated the highest absorption capacity for both pharmaceutics, reaching removal efficiency close to 100%. And in contrast, the other samples exhibit very low adsorption with only few percent removal. At the bottom in this table, we have the kinetic results. The data fit best with the pseudo second order kinetic model, suggesting, according to some authors, that hemisorption could be a dominant mechanism. We see that adsorption capacity for CN sample is very low, while CP samples show much higher experimental and calculated values around 50 milligrams per gram for both pharmaceutical. These findings highlight again that activation process by phosphoric acid is the most led to produce of most effective adsorbent in for removing pharmaceutical that we test. And this is my last slide. I would like to summarize the achievements of this short-term scientific mission, the planned goals and expected outcomes. We think that we were successfully reached, especially in terms of generating new experimental results. And one important aspect that I will is capacity building through the active involvement of one researcher, one young researcher, and one PhD student. They contributed to the synthesis of activated charcoals or biochars, adsorption testing of organic pollutants, and data analysis performed in our institute. And they work, one of them is present here. It's our PhD student, Jovan Parlić. He is today here with us. And their work will be recognized through the co-authorship in the oncoming publications. As key deliverables, this webinar is one of the first deliverable. Further results will be presented in the 18th International Conference of Fundamental and Applied Aspects of Physical Chemistry, 2026 in Belgrade, organized by our university. And we're also planning to publish one research article that will be submitted to pre-reviewed journal to the end of this year. And all the deliverables will be, of course, with acknowledgement to the support of COST Action. So if you have something to ask, to discuss, I'm open, and thank you for your attention. I hope that I was in the suggested time for the presentation.
Yes, you were. Thank you. And also thank you for acknowledging COST Action. It is very important for us when after grant periods we have to give proofs to the European Commission that our work is visible, and the easiest way to show it is to show the publication records with our cost name or the number. So thank you for that.
Okay, of course.
And does anyone have questions or comments?
Maybe short comment.
Yes.
Your presentation was very, very fast. Yes, I should check this presentation again to understand more, to be honest. Yes, because you presented us a lot of very difficult information. But finally, on the last slide, I see very, very promising information, yes, about presentation, about paper, etc. Yes, and I like your precision. I like that you are so complex, that you remember about everything, that you are aware that we need this information. This is for our action very important. And I want to say thank you very much, Nataša, that you do really good job for our action. Thank you very much.
Thank you very much, Magda, for your kind words. My presentation was toward really STSM achievements and deliverables. And I think that in the following presentations through the conference and paper, all participants will be have they can see the complete research with all informations and all characterization and other details regarding the research.
Okay, thank you very much.
Thank you.
Thank you. Do we have more questions?
Yeah.
Comments? If not, then I would like to ask Zorica to present.
Now try to share window.
Okay.
I just to manage. Okay.
Sure.
Now do you see?
Yes. Yes.
Okay. Everything is okay. So I was lucky to be at the same time and in the same place as Nataša. Nataša and I come from the same institution, and a lot of our research interests overlap. So we asked for the STSM at the same time, and we are very thankful for this COST Action for enabling this. So my hosts were also Maryam and which I have profound thanks for their help. So the topic of my investigation was characterization of biochar obtained by catalyzed pyrolysis of sawdust. What that is actually. Actually, I was mixing sawdust with some alumina in different alumina and different ratios of this alumina, obtaining biochar alumina composite. This type of investigation is done for the last 10 years, I think, or maybe more. But the accent of the investigation was on the products of these process, like biofuels or other liquid or gaseous products, not on the biochar. It was considered waste, or if it was investigated, it was investigated for absorption properties and so on. I'm electrochemist and I always investigate new electrode materials. So I use this biochar alumina composite as an electrode material. And the aim of this STSM was to provide me with some textural and morphological characterization so I can corroborate some findings that I was doing by my electrochemical research. So to present, we used one sawdust obtained biochar, but I used two alumina types. Sorry, yes.
I think we don't see the changed slide.
Okay, do you see now?
Yes, yes.
Okay, I'm sorry. So again, this was that talk about what was done. So I was mixed sawdust and alumina obtaining biochar. You see now, next slide now.
Yes,
Jakub?
yes.
Yes, okay. So I made one biochar sample using sawdust and two alumina types. This anhydrous alumina type and trihydrate alumina type, and three different ratios between sawdust and both types of alumina. And then I made electrode by making carbon paste electrode in this manner and filling this hollow tube with provided contact in electrode. To select what material, I had a larger number of samples and it would not be wise to analyze all of them. I performed some electrochemical characterization previously, and usually it is done to investigate electrode response towards some of well-known redox probe, in this case iron hexacyanoferrate, and it provided me with some understanding how charge transfer occurs on my electrodes, but I planned to use this electrode for investigating concentrations of pendimethyline, that is herbicide, which is forbidden in a lot of countries. And the best results was obtained for the biochar alumina composite with type A in the ratio 2:1. Therefore, that sample has been selected for characterization, but also its counterpart with other type of alumina in the same ratio, as well as biochar alumina and whole type of alumina to provide a comparison to see what happened. Sorry, just a second. Okay. These are the results of STSM analysis, and we can see the biochar samples mostly preserved wood-like structure with agglomerates with about 200 micrometer sample. That alumina A-type is mostly spherical, while T-type alumina has more crystallized aggregates with species, but these are composite biochar. And you can see that the aggregates coming from biochar are smaller. That A-type alumina mostly preserved its structure, while T alumina shows more decomposed structure, that it was more affected with this pyrolysis process. This is the instrument we used in CIMAO organization, and these are isotherms I obtained during that visit. And we can see the biochar is presented on both figures for comparison reasons. Has almost no surface area. It's very low. It's 1.5 square meters per gram. While A-type alumina has this isotherm, which can be classified as 4-type isotherm with a lot of rise of nitrogen uptake here, which is usually explained by capillary condensation mesophores. Composite has much lower curve with much lower surface area. The same thing happens with the T-type alumina, but composite has very, very small surface area. Difference is very high, and possible explanation is that formed carbon during pyrolysis is clogging, blocking those pores, and that interaction is much higher for this type of water. These findings will help me to better explain my electrochemical results, and in that manner, these are deliverables resulting from this STSM. This presentation and this webinar conference paper that will be presented at the Advanced Ceramics and Application 13. This conference will be held next week in Belgrade, and as soon as I have excerpt from book abstracts, I will send it to you if it's acceptable. Manuscript detailing obtained results is in writing. About 80% of it's finished, and I expect that the first draft version will be finished by the end of September and submitted somewhere in October. I expect that this kind of STSM and these results will be help to widening application of biochar and biochar composites, adding to the work group 5, and I hope that electrochemical characterization of biochar samples would also be helpful for characterization. This figure presents pesticide science. During synthesis of these composites, I used ceramic vessels, and they were wrapped in aluminum foil to provide air-limited conditions. But after the synthesis, I found out that the vessel changed color and I found it really, really nice. But this color is not permanent; it can be scrapped. So these are, you have already seen this picture, but thanks again to COST Action and our host, and thank you for your attention.
Thank you.
You managed to see. Okay. So do you have any questions? I make this short because we have been at the same time, and all other relevant information you get from Nataša, so there's no reason to repeat that.
Yeah, but I saw that the research was completely different.
Yes,
right?
we tried to make different. We overlapped in some things, but we try to follow each other. But we have both of us have our expertise, and we was similar but different research.
Yes, the same. You made the same analysis, right? But on different
materials. Yes, I made the same analysis, but on different material for different application.
Yes, that's great. Yeah.
Thanks.
So, any comments or questions?
maybe from my side, short comment. So to be honest, Zorica and Nataša, in the range of core group, we were afraid if this is a good idea to give you the same STSM's grants, yes, because this is the same institution, etc. So we were afraid that this investigations will be very, very close. But it turned out, as Kuba mentioned, that these investigations are totally different. And I see that you are going to do also completely different examination after STSMs, because you are going to participate or to present this research on different conferences. And thanks to this, we will obtain better examination of our action, and you are going to publish 2 papers at least, I hope. So this is a very big input for our action. Thank you very much again for this participation and for your engagement. Thank you very much.
Well, thank you for having faith in us that we are going to do real research, not just to go together.
Okay, thank you very much.
And please expect from our side a contact during the reporting time, because we will need to gather the informations. This will be my task.
I plan to send you the excerpt from the book of abstract as soon as the conference is over. As soon as I have material, so you can put it in your base or whatever you do. And I think I will post some on LinkedIn, so that is also to hashtag everything that needs to be hashtag, so you will have also that.
Thank you. That's great. Thank you. So I think now we can proceed to the third presentation by Maryam.
Hello. Yes.
Hello.
I think I have to also put up the camera to keep the net connection stable, as I'm sharing also the document here.
Okay, sure.
I assume now you have the full mode presentation.
Yes.
Okay,
it works
good.
Perfectly.
Yeah. Yes, I'm Maryam Ghalibaf, and I'm from the Natural Resource Institute, Finland, and I will talk about my STSM research visit experience about the production of the biochar-based composite. This research visit to the Department of Applied Science and Technology Polytechnic of Turin in Italy was about the high diversity needs of the forest byproducts, such as potash, tar, resin, and charcoal, meaning in this case, biochar, has motivated this research to Polytechnic Turin. It was about 2 weeks in hot summer in Italy, and it was working under supervision of the Professor Rosalla and her PhD student Fulvia, who were standing next to me in this picture. And I appreciate also from here their support and assistance. If I'm also giving very short introduction about my professional background, I'm a PhD degree in applied chemistry from Finland. I had also other kind of visiting exchange research during my doctoral study, one in Finland and also in Netherlands, and it was very long comparing with this 2 weeks short scientific research mission. And also I got my doctoral, postdoctoral research in the Netherlands, in the same group that I had also the visiting research with them. That's why it was very nice experience, and was a kind of motivation for me that this kind of research visit, even though very short, can really give the opportunity to the researcher to expand the network and then continue the new research topic. And in Finland, I'm working in the Natural Resource Institute, and then also I had the experience working with 2 different groups inside this organization. And then about my role in a COST Action is that I'm the member in the management committee and also the work package 5. So now back to my research visit to under this COST Action. About the biochar in polymer composites, and then why this topic under this STSM research visit was important. It was because the demand of the new eco-friendly product like this biochar has been increased in this production of the polymer-based composite, because recently the natural fiber was having the main role in the composite, but then due to the low thermal stability of these natural fibers and the poor compatibility with the polymer, they get the more problematic in the polymer matrix. Therefore, the use of the biochar in the polymer-based composite now is showing more promising alternative and attractive to this research field, because as also the previous presenter also talking about the surface area, and then the properties of the biochar can be a kind of the good base for being in this composite. Also, my research visit was something about the biochar. Biochar, as also previously it was mentioned, that it's a solid product that obtained from the thermochemical conversion of biomasses in an oxygen-limited environment. By playing about the pyrolysis condition, it's possible to make the uniform carbon base and porous structure that can attract with the polymer functionalities. That's the important things, that what type of the biochar we are looking, and then we are thinking about to make this biocomposite. The biochar that I used during this research was wood-based biochar, like from the softwood and hardwood and the pulp and paper waste material, which we obtained from some of the companies in Finland. About the properties of the biochar, I cannot share the data in this presentation because some of those is not ready, and then because it was this STSM research visit was the extension research about some of the ongoing project. That's why, and then we are having the kind of a schedule that the characterization will be done soon. And also some of the things that the data is not complete in this research visit, as it was in the August after my research visit to Italy, and August was the holiday season in Italy, and the PhD was supervising and assisting me during my stays. Is the finalizing her own PhD. That's why it just really made us that we couldn't fulfill the whole characterization, but then we have the plan for that. And then about this biochar-based composite, which was the main activity I completed during my visit in there, that the biochar was incorporated to the selective polymer, which was thermoplastic ethylene vinyl acetate, through the melting mixing bender. You can see in this picture. It was my first time working with this machine. That's why it was good and also challenging for me. But I obtained a good experience about this field also. The work was that optimization of the tree ratio of the biochar, and then we selected from the 10% to the 20%, but then we found out that the 10% ratio was the best optimal amount for this incorporation, which below the picture you can see that if we added more biochar, that it could not be incorporated. That's why we understood that we have to change the amount of the biochar. And the main things about this was that really very challenging, that the essential part of the process was thorough cleaning of this bender after each batch. This step was critical to avoid the cross-contamination between different biochar samples and to make sure that the accuracy and reproducibility of the result are really good. And that was very timing process, but at the end I could make the total of 5 composite, including the 1 reference composite without the biochar and the other 4 with the biochar. The next step after making the biocomposite, that you can see that in one of these pictures are shown, that one with the pure polymer and another 2 black one was that including the biochar. After that, I had to do the STSM preparation from the biocomposite into the standard shape. Here it's the this cycle shape through the thermocompression molding for the rheological testing. The molding was also performed under the control condition to ensure the uniformity and the consistency across the all STSM. And the all condition was set to the same condition for that bender. The one characterization method I could use, it was the rheological method that I could conduct it on the tree composite due to the time limitation, because all of this working, if anyone worked with the polymer and this kind of field, they know that the working with the machine is very time consuming, and really it was the kind of the difficult also working with the hot devices during the hot summer in Italy. But then I was managed to make the all sample, but then the characterization was something that left out. But then based on that tree characterization I could do with the rheological measurement, that it shows that the biochar addition was found to enhance that thermal stability of the polymer matrix. And it was the good sign, but then I don't have the data to show here how the graph is showing. But then what we saw there, it was interpreting to that the biochar addition was the good and then having the positive impact on the composite. For me, it's not complete deliverable, but then we have quite good plan for the next step. I can say that this STSM research visit allowed me to obtain the hand-on experience in the field of the polymer chemistry. And also I could explore the future opportunity for collaboration. But we plan to complete the set of the characterization method I listed here in September. And also we are aiming to write a scientific paper on this result. And for sure, this is very interesting topic, and we are happy to continue collaboration later on. And I appreciate COST Action to give this opportunity also to me to visit a new research group and then expanding my network. Thank you very much.
Thank you. We would also like to thank all the participants of our grants to apply and to the will to join other groups or go to the conferences is very important for us, because we need participants to fulfill our goals. So thank you for the STSM which you took and all the research which you made. We can clearly see that in our action, the biochar is really strong part. We have a lot of ongoing activities with the biochar, and yeah, we think that's. I didn't know that much about the biochar until I joined the action, and we in Poznań you have a tar, more like laboratory. So it's for me it's very interesting to see and hear all the things according to the biochar and charcoal. Does anyone has comments or questions?
Maybe in short.
Yes,
oh, yes, Oliver, sorry.
Yes, please. Thanks, Maryam, for the nice presentation. I wonder, these polymers you integrate biochar in, as far as I understood, I'm not from the field. What are they at the end? What are they used for? Maybe I missed this point.
Yeah, it is that because it has the kind of thermal stability that they want to use it for some kind of in the construction material as a fire barrier, something like that.
Okay. Mm-hmm. Okay, thanks.
Sorry, maybe now can I say something?
Yes.
Okay, thank you very much. Yes, Maryam, thank you very much for your presentation, of course. And as Jakub mentioned, today we have a charcoal series. It's good because this is the most popular material which we work in the range of our COST Action. But I hope that future STSMs, maybe yours, will with I am waiting for PoTaRCh, for example, or I am waiting for pitch or tar, yes. So I hope that your future applications will be related to also other materials, because I see that you are able to do a lot of research, very valuable research, and I hope that you can also analyze other materials which are in the scope of our COST Action. So I am waiting for your presentations, maybe on the different conferences, and I am waiting on your papers, articles after the STSMs, and believe that you are continued deliverables of our action. Thank you very much.
Yeah, for sure. This research paper is something that I can promise, and we will do that. But then the organization I'm working in, it's really, we need the travel budget for participating in the conference. And if it is not related to any project, then it means that we cannot really present the data. And I hope that, yeah, I can just present as a webinar some other places,
Yes,
even in our organization.
We know this limitation, so we understand, of course, yes. But please remember that we have in the range of our cost action of also conference grants. Yes, so this is also good option.
Then I would apply that, yes.
And we will start the next grant period with new budget, yes, so.
Yeah, sounds good, yeah. It is really nice, yeah, thank you.
Okay, thank you very much again.
And I see that Zoe is with us. Would you like to say something about the haiku workshop? We can't hear you.
Sorry.
No
Yeah,
problem.
sorry I was late. Sorry I was late joining. Yes,
problem.
and I'll just say a bit about next week's haiku workshop event. And I'll start by saying sorry as well about the confusion yesterday about the various meeting invitations. There was a bit of confusion with the time zones, but hopefully yesterday afternoon you should have received the correct invitation to attend the workshop next week. So it's a workshop to guide you through writing a haiku, which is just a short form of poetry on any topic that you want to related to our PoTaRCh action. It's going to be a really enjoyable experience, and it's going to be very supported. So we'll be given a few sort of guided tasks to help us achieve writing a haiku. So don't be scared or worried about the process if you've never done anything like this before. And the hope is, yes, for everyone to contribute a haiku, which will then collate in a small publication afterwards. So yes, we look forward to seeing you next week. It's just to confirm then, it's on Thursday the 11th of September, and UK time it starts at 11, but I think that's Central European Summer Time is 12 o'clock, so midday. And if you've got any questions in the meantime, do please email me.
Thank you. And I'm looking forward to see as many people as possible on the haiku workshop. I know that I still have to properly register, but I will do it soon.
Oh, don't worry now. If you tell me I wanted to get an idea of the sort of the numbers of people who might attend, and also the countries and the geographical spread that would be represented. But I think as long as you go through the cost action thing now, I think the invitation, then that's fine.
Okay, so yeah, I click
so,
accept there.
Thank you. Yeah, lovely. Lovely. Thank you.
Okay, so thank you for today's presence, and see you hopefully next week on a haiku workshop. Have a nice day.
Thank
Bye.
you.
You too, thank you.
Take care. Bye.
Bye.
Bye. Bye.